All right, well, hopefully everybody had a great spring break and is still healthy. We're going to start a chapter off on sequences and series, but first we're going to be talking about sequences. So the first one we're going to talk about is arithmetic sequences, which is actually very, very simple. It just means we're adding or subtracting by the same number every time to get from one term to the next. So here's an example of a sequence problem. So we can see the numbers there, 3, 4, 5, 6, all representing number of shingles in a single row. So the sequence is just a list of numbers in a particular order, and then each one of those numbers we call the term. So notice, if we look over here on this, our first term, term 1, is 3. Term 2 is 4. And so on and so forth. So we can see that it's an arithmetic sequence because we're adding by 1 every single time. And what we add or subtract by is called the common difference. So we're going to denote these. If you ever see, like over here, we see that a sub 1, that's just referring to the first term. A sub 2 is the second term. So notice there isn't really a zero term here. We always start with our first term in a sequence. All right. So the first thing we need to be able to do is just find terms of an arithmetic sequence. So hopefully you're looking at this problem, you're like, yeah, this is super easy. So we want to find the next 4 terms here. So we got 55, 49, 43. So we need to look at it and we got to find the common difference. So hopefully we see there that we are subtracting by 6 or adding by negative 6, however you want to look at it, each time to get from one term to the next. So, and we found that by subtracting a term by its previous term. So our common difference here is negative 6. So all we have to do is just keep subtracting 6 from one term to the next. So notice if we subtract 6 from 43, we get to 37. Subtract 6 again, we get to 31. Subtract 6 again, 25. And subtract 6 again, we end up at 19. So that is the next 4 terms. So this would be a sub 1, a sub 2, a sub 3. There's a sub 4, a sub 5, a sub 6, and a sub 7. All right. Easy, right? So these are the 2 formulas that we're going to be using. You can use either one. This is kind of, we have to go through and understand what's going on here. So this would be our first term. N is the term that we're trying to find. So if we're trying to find the 15th term, we would plug in 15 for N. And D is our common difference. Now this one is the exact same formula. It's just using the zero term. So if we can go backwards and find the zero term pretty easily, this one might be an easier formula to use. Notice it looks just like slope-intercept form, which is different variables. Think of it as y equals mx plus b. It's the same thing. So one of the other things that I forgot to mention was that arithmetic sequences are discrete, not continuous. So we don't connect the dots if we are to graph them. So we only plug in a 1 and get out an answer, then plug in a 2 and get out an answer. We don't plug in decimal values or fractions. Alright, so here we need to write an equation to represent this sequence. So we have to find all those missing pieces for our formula. So I'm going to go through with using the first formula and explain it. So notice here our first term, a sub 1 is 8, and our common difference is 9 because that's what we're adding by each time. So all we need to do is plug in those into our formula here. So we got a sub 1 is 8, and the common difference is 9. And then we're going to need to distribute everything through to simplify it. So if we distribute the 9 to the n, we get 9n. And then we distribute the 9 to the negative 1, we get negative 9. And now we can combine like terms. So there is our formula. So 9n minus 1. So now, if I asked you to find the 50th term, you would just plug in 50 for n and work it out. And that would tell you what the 50th term is. Alright, so let's say we wanted to use that other formula that I had in the previous slide. So I've got that up here now. All we'd have to do is go backwards to find the zero term. So we're adding by 9 each time. If we come back up and look up here, notice we're adding by 9. So if we want to go backwards, we subtract 9 to get back to our zero term. So 8 minus 9 is negative 1. And we know that our common difference is 9. So I could actually just say like t sub n is equal to our common difference of 9n, and then 8 minus 9 is negative 1. So notice we kind of were able to skip all this work by using that formula. But it's totally up to you which one you want to use. Alright, so now we also might want to find arithmetic means. So our arithmetic means here just means we're missing some values. So what we can do here is use what we know and use our formula. So we know that our first term is 16 and our sixth term is 91. So we're going to use this formula here. So right here is a sub n. That's where we're going to plug in our sixth term. A sub 1 is right here. So we plug in 16 there. And n, since this 91 is the sixth term, we're going to plug in a 6 for n right here. And then we've got to solve it for d to figure out what our common difference is. So we plug all that stuff in. We distribute d through, or actually we don't have to distribute, we need to combine our like terms, sorry. So we end up with 5d. So now we just got to solve for d. So we subtract 16 from both sides, and we get 75 equals 5d. And then we divide both sides by 5, and we get our common difference is 15. So that means we just have to keep adding 15 from 16 plus 15, add 15, add 15, add 15, and that'll find our missing values. So here's the description of that. So plus 15 is 31, plus 15 is 46, plus 15 is 61, and plus 15 is 76. So we can see that we found all of our missing terms there. Alright, so below this video I'm going to have a few problems that I want you guys to try, and then there'll be video solutions for those as well. But I want you to try them on your own and make sure you know what you're doing. And then there will be a multiple choice assignment for you to complete once you've tried the practice problems. So I hope everybody has a good day. If you have any questions, feel free to email me, message me on Canvas. I will be online to answer questions. Alright, so have a great day.